54. Find the LCM and HCF. This was the homework question. Okay, how many of you got the answer? Completed? How many of you completed this? What is the HCF and LCM? What about others? LCM, I think some other number. How much you got the LCM? Okay. So I will quickly do this one. 336 and what's the second number I gave? Yes, 54. 336 and 54. So first of all, we factorize 336. So Sarah got 6048. Anyone got 6048 as the LCM? 336, how do you factorize 336 by 2? By 2 when you do. Yes, those who are not done, please complete it. 1 2s are 2, right? Then 3 minus 2, 1, 13. 6 2s are 12. Okay. Then how much we get? 1. So 8. 168. All of you got the first factor, first one, 168. Is that clear? 3 by 2, that is 1. Oh. And then again by 2. So 8 2s are 16 and 4 2s are 8 by 2. 4 2s are 8 and 2 2s are 4 by 2, 2, 1. By 3 it is 7, 7 it is 1. So what is 336? 1, 2, 3, 4. 2 raised to 4 into 3 into 7. How many of you got this factorization correct? Yes. 2 raised to 4 into 3 into 7. Yes, what happened in that one? 168 was the confusing. Yeah, please correct it. No. With 3, it's fine. But finally you will get the same. 2 raised to 4, 3 and 7. You got it? Got it. Okay. Abhirami got 6 as the HCF and 3024 as the LCM. Anyone got 3024? Yes. 3024 you have got. Next is 54. 54 we factorize. 54 is divisible by what number? By 2. So 2 2s are 4. Then 1 means 7 2s are 14. 27. So this is by 3. 9 3s are 27. By 3, 3. So we get 2 into 2. We write exactly below 2 raised to 4. And 3 to the power what number? 3 raised to 3. 3 raised to 3. Yes. Your name Benita, right? Benita got this step correct, 54. Yes. Then we have to write HCF. HCF, in this one, it's a common factor. In this one, what is a common factor? Yes, so these are the common factors. So 2 raised to 4 and 2 in that one, the smallest power in that common ones we take. So 2 into 3 is the HCF. Is it clear, this writing? HCF we can take only from the common factor. Common means the one which is present in all. Okay, 2 raised to 4 is there, 2 is there. So we take the lowest power, that is 2. 3 is there, 3 cube is there, we take 3. We cannot take 7. Why can't we take 7? Because there is no 7 in the other one. Okay, 7 is not a common factor. So HCF is 6. Those who got HCF put the tick mark. Only those who got the answer. HCF is 6. Yes. Steve, left margin you will draw for every page. Okay. Now next is LCM. HCF is 6. LCM is 2 raised to 4 into 3 cube into 7. Is it clear how it is written? 2 raised to 4. From the first one, 2 raised to 4. The highest power should be taken. Next is 3 cube. Next, for non-common factors also, we can take it. So it is 7. Multiply. 2 raised to 4 is 16. 3 cubed is 27 into 7. Multiply this. 16 into 20, that into 7. Yes, Raswana and Abhirami got the correct answer. 3024. Those who got 3024, please put the tick mark. How many of you got here 3024? Yes, you can put the tick mark. 3000. Others, please do the correction. 3024. Okay. Then we do the verification. Verification. This verification is normally for 2 numbers. This is applicable for 3 numbers. We cannot do this verification. This is for 2 numbers. Okay. So what is the verification? LCM into HCF. LCM into HCF is equal to 6 into 3024. Please multiply 6 into 3024. How much you are getting? All of you, please multiply. Yes, those are already done. What is your product? 1814. 4. 18144 is correct. Then product of the numbers. Product of the numbers is 336 into 54. Product of the numbers. Product of the numbers. That is 336 into 54. Yes, please multiply. Did you get the same answer? Yes, same answer. Then you will write the conclusion. That is LCM into HCF is equal to product of the numbers. Hence, it is verified. That is LCM into HCF is equal to product of the numbers. Hence, it is verified. Hence, it is verified. Please write down. LCM into HCF is equal to product of the numbers. Hence, it is verified. This is the completion of this question. Next, we are going to start with the 3 numbers. Find the LCM and HCF of the following by prime factorization. Please write. Find the LCM and HCF of the following by prime factorization. Find the LCM and HCF of the following by prime factorization. First question, 12, 15, and 21. First question, 12, 15, and 21. Right. First question, 12, 15, and 21. Find the LCM and HCF of the following by prime factorization. Question number 1, 12, 15, and 21. Okay. So here also we do the same way. Here verification is not required for 3 numbers. It is not asked as well. We have to factorize 12, then factorize 15, and factorize which one? 21. The same way we will write the same common prime should be on a line. First of all, I factorize 12. Yes, 12. How can we factorize 12? Divisible by what number? 2. 6 2s are 12. Again, 6 is divisible by 2. It is 3, then 3, 1. So 12 is equal to, yes, how do you write 12 is equal to? 2 square into 3. Yes, all of you please write. 12 is 2 square into 3. Next, we do 15. Yes, 15 is direct. What is 15? 3 into 5, 3 into 5. So we write 3 here and 5 here, 3 into 5, 15. Next, 21. Yes, 21 also we can write directly. 21 is 3 into 7. So 3 we write here, 7 there is no slot. So I move here and then I will arrange it like this, 3 into 7. Now for HCF, we have to see the common prime. What are the common primes here? 3. 3 is present in all these places. So we write HCF is equal to yes. What is HCF? Is 3. HCF is equal to 3. HCF is equal to 3. Right. HCF is equal to 3. HCF is 3. Next, LCM. For LCM, we have to multiply each and every prime. Yes. What are the primes to be multiplied from the first one? Next one, 3. Next one, multiply. 2 square into 3 into 5 into 7, multiply. 2 square into 3 into 5 into 7. Please do the multiplication. 2 square into 3 into 5 into 7. Yes. 2 square is 4. So 4 into 3 into 5 into 7. 4 into 5 is 20. 20 into 3 is 60. 60 into 7, 420. All of you got 420? Yes. So this is the completion of this sum. We found the LCM and HCF. It's perfect, right? Yes. One more question. 17, 23, and 29. 17, 23, and 29. What is special to these numbers? All are prime numbers. If all are prime number, we'll write the HCF as 1. 1 is the common factor. There is no other common factor. Because of this reason, 17 is, and LCM will be the product of the numbers. LCM will be the product. That will be like this. 17, we can write 1 into 17. 23 means it is 1 into 23. So I write 23 after moving a space here. And 29 we can write as 1 into 29. 1 into 29. Okay. Because of this reason, the common factor in all these things, there is no other common factor. So we'll write 1 as the HCF. Don't write 0. Okay. It is 1. So please write it in this order. And because of this reason, we get LCM is the product of the numbers. 17 into 23 into 29. Are you getting? Please write. So here HCF is equal to 1. Here HCF is 1. And LCM is equal to 17 into 23 into 29. Please multiply this one. 17 into 23 into 29. HCF is 1, LCM is 17 into 23 into 29. Multiply. Okay, what is the product? Yes, those who completed online, you can send your answer. Yes, your answer is correct. You got it? Correct answer. You got the answer. What is your answer? Correct. Okay, so 11339. Abhinami got the correct answer. Sarah, correct answer. 11339. So you understood this concept. In case if there is no common factor, HCF is 1. HCF is 1. Okay, this category also I'll give one homework question. This one as answer is also correct. This category of one homework question is 8, 9, and 25. Please note down. Homework. 8, 9, and 25. 8, 9, and 25. Please note down 8, 9, and 25. Okay, so you will factorize 8, you will factorize 9, and you will factorize which one? 25, and we'll get the answer. Next, we have very important questions will be there in the examination based on LCM into HCF is equal to product of the numbers using that concept, okay? So using that concept, we can find out either one of the missing number or LCM or a HCF, okay? Using this, we can find out. So this will come there in this MCQ or 2 marker. So please write that type of a question, very important one. Given that, right, given that HCF of 306, 657 is equal to 9. Given that HCF of 306, 657 is equal to 9, find LCM of 306, 657. Please write. Given that HCF of 306, 657 is equal to 9, find LCM of 306, 657. So here we use the formula LCM into HCF is equal to product of the numbers. What's the formula? LCM of AB into HCF of AB is equal to A into B. Okay, we will apply that formula. LCM of AB into HCF of AB is equal to, what's the formula we studied? A into B. Okay, according to this formula, we can write LCM of 306, 657 into HCF of 306, 657 is equal to 306 into 657. Is it clear, this writing? So we find the LCM. So we find this one, LCM of 306, 657. HCF is given. How much is the HCF given? 9. So in place of this HCF, I substituted 9 is equal to 306 into 657. All of you understood the step till here? Now, how do you find the LCM from here? We have to take this into 9 to the other side, right? When you take multiplication by 9 to the other side, what will happen? Division, right? Multiplication, its opposite operation, that is division by 9. So LCM of 306, 657, not 9, 657 is equal to 306 into 657 whole divided by 9, please write. So then we can do the cancellation. 9 and 306 we cut. Yes, what do you get when you cut 9 and 306? 9 into what number? 9 3s are? Yes, 27, then 36 means 9 4s. So we get 34. Is it clear the cancellation? 9 and 306. 9 3s are 27. Then when I subtract, I got 3 as the difference. So 36. 9 4s are, so 34. Then multiply. 34 into 657. When you multiply, you will get the answer. All of you, please multiply 34 into 657. 34 into 657. And tell me what is the answer. 34 into 657. Yes. All of you got the answer? Chris completed. Your name, Alicia? Your name? Afreen. Afreen got it? Yes. Joan got the answer. Sharon got the answer, right? Sarah and Ruswana and Abhirami. Yes, all three got the answer. So, children, answer is 22338. Got it? Steve, great. Multiply this one. Multiplication also, you have to get the speed. We cannot use calculator in CBSE. Okay. So, other British syllabus and all, they allow calculator for multiplication, but CBSE they don't allow. Why? Because to improve our calculation skill, the speed of calculation. So you have to practice that also when you practice the sums at home, multiplication, so that you will get the speed of multiplication and the accuracy in multiplication at home. So the answer is 22338. This is the answer. LCM is so this is very, very important. So here HCF may be missing, LCM will be given. So that also we do the same process. Okay. Some questions LCM and HCF will be given. One of the numbers will be missing, other number will be given. So we do the same process. We take this given number to the left side as a division and we find the number. Clear? Okay. So anyway, this formula you have to remember and practice well. Next in that exercise, first of all, we do the exercise questions. We have a few questions remaining. Next is a theoretical based question. Please write. Check whether, this is a 3-marker question. Check whether six raised to n can end with the digit 0 check whether 6 raised to n can end with the digit 0 for any natural number n. For any natural number n. Please write. Check whether 6 raised to n can end with the digit 0 for any natural number n. Okay. So this is an application of our fundamental theorem of arithmetic. You know, fundamental theorem of arithmetic. Every composite number can be expressed as a product of prime factors. And this factorization is unique apart from the order in which the prime factors occur. So this is an application of that one. So we will factorize 6 raised to n. 6 can be factorized as 2 into what number? 2 into, so 2 into 3, the whole raised to n. This is the first step. Then, if the, wait, don't write. If the number 6 raised to n, that would end with the digit 0 if it is divisible by what? What type of number end with the digit 0? Divisible by? Divisible by? 5 or 10? All divisible by 2 numbers end with 0? No. All divisible by 5 numbers end with digit 0? No. 55, for example. So if a number end with the digit 0 means it should be divisible by both 2 and 5. 10. Is it? 10's multiples will end with the digit 0. That means we have to check whether both 2 and 5 are there in the factorization. Here there is only 2. 5 is not there. Are you getting? Multiples of 10 we have to get. That means 2 primes must be there. Must 2 and 5. Any extra prime can be there. That is not a problem. But here only 2 is there. So can it end with the digit 0? No. So this one I will write in the next line. So first of all, we'll write that explanation. So please start like this. If the number if the number if the number 6 raised to n ends with the digit 0, then it will be divisible by what? It will be divisible by 10. If the number 6 raised to n ends with the digit 0, then it will be divisible by 10. Okay. That means it must contain the primes 2 and 5. That is, it must contain the primes it must contain the primes 2 and 5. 2 and 5. That is, it must contain the primes 2 and 5. It must contain the primes 2 and 5. But 6 raised to n is equal to 2 into 3, the whole raised to n. That is 2 raised to n into 3 raised to n. That is the prime 5 is not there. The prime 5 is not there in the factorization of 6 raised to n. That is the prime 5 is not there in the factorization of 6 raised to n. By fundamental theorem of arithmetic, by fundamental theorem of arithmetic, 6 raised to n is equal to 2 raised to n into 3 raised to n. Is the unique factorization of 6 raised to n. That is a fundamental theorem of arithmetic says this factorization is unique, right? We cannot express, we cannot write a 5 according to our wish. So this is a unique factorization. So 5 is not there. 5 is not there means we will not get multiples of 10. We will not get multiples of 10 means can it end with the digit 0? No. Therefore, 6 raised to n cannot end with the digit 0. Therefore, 6 raised to n cannot end with the digit 0. Six raised to n cannot end with the digit 0. digit 0 for any natural number n. Okay, so this is the completion of this question. Oh. 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 Because 10 must be there in that factorization. 10 must be there means 2 into 5 should be there. Are you getting? 10 means 2 in 10 or any multiple of 10. 2 and 5 must be there. If one among them, if it is there, we will not get multiples of 10. Okay, multiples of 10 we are not getting means it cannot end with the digit 0. Once again, you see the wordings of this one, okay? So the same way you have to write. Even that fundamental theorem of arithmetic concept also you have to write. Okay, for that point, the teachers will give the mark. Okay. This is a 2 marker or 3 marker. 2 marker or 3 marker type question. Okay. Yes. Last time, I remember last examination, I think this batch. One student forgot to write this sentence. He lost 1 mark by fundamental theorem of arithmetic. Okay, that is the main point. By fundamental theorem of arithmetic, we cannot add a 5 according to our wish. That's what this factorization is unique. All of you understood the meaning or the method of writing. I mean, the method of writing, if the number 6 raised to n, where to end with the digit 0, if it is divisible by, divisible by 6. Or if it is, if it ends with the digit 0, then it will be divisible by 10. Okay, that is, it must contain the primes 2 and 5. But 6 raised to n is only 2 into 3, the whole raised to n, or 2 raised to n into 3 raised to n. That is, the prime 5 is not there in the factorization of 6 raised to n. Is it clear? Okay, by fundamental theorem of arithmetic, 6 raised to n is 2 raised to n into 3 raised to n is a unique factorization of 6 raised to n. Okay, therefore, it cannot end with the digit 0. The logic is, it must be divisible by 10, means 2 and 5 must be there. Similar type of one more question is there as a worked out example. We are going to do that also right now. Same wordings we'll write for that one. So please write. Yes, those who attend online, did you complete this one? And it is clear, right?
Yes, sir.
Ruswana, any doubt?
No, sir.
It's clear. Okay. So next question. Check whether check whether 4 raised to n can end with the digit 0 for any natural number n. Please write. Check whether 4 raised to n can end with the digit 0 for any natural number n. Yes. Can you try? Same way. The number 4 raised to n, where to end with the digit 0, then it should be divisible by 10. What's the sentence you can write? If the number 4 raised to n ends with the digit 0, then it should be divisible by 10. If the number 4 raised to n ends with the digit 0, then it should be divisible by 10. But what is 4 raised to n, children? 4 raised to n is equal to 2 square the whole raised to n, right? Or 2 raised to 2n, or 2 raised to 2n. 4 is 2 square, is it? 2 square the whole raised to n. Last year we studied a raised to m, the whole raised to n is a raised to m into n. So 2 raised to 2n. Here also, what prime is not there? 5 is not there, right? 5 is not there. 2 and 5, both should be there, right? 5 is not there. So please write. That is, it must contain the primes 2 and 5. That is, it must contain the primes 2 and 5. Last one, we wrote like that. That is, it must contain the primes 2 and 5. Okay? Then we'll write the same way. The prime 5 is not there in the factorization of 4 raised to n. Can you write? The prime 5 is not there in the factorization of 4 raised to n. After writing the other two sentences, I did not write the other two here again. I did not repeat, but you have written, right? Yes, then you will write. Yes. Therefore, by fundamental theorem of arithmetic, this is the unique factorization of 4 raised to n. By fundamental theorem of arithmetic, by fundamental theorem of arithmetic, 4 raised to n is equal to 2 square, 2 raised to n is the unique factorization of 4 raised to n. Unique factorization of 4 raised to n. Therefore, 4 raised to n cannot end with the digit 0 for any natural number n. Therefore, 4 raised to n cannot end with the digit 0 for any natural number n. So this is perfect. Now, what type of numbers are composite numbers? Last class we studied. A number which has more than 2 factors. Okay, one and the number itself, then at least one more factor extra. What is the smallest composite number? 4 is, last class we discussed that in detail. 4 is the smallest composite number. Okay, so then what is the next composite number after 4? 6 is the next one, right? 6 is 2 into 3, 2 and 3. 1, 2, 3, 6 are there. So 6 is the next one. Okay, so please write this one. Explain why. Question. Explain why. Right. Explain why 7 into 11 into 13 plus 13 is a composite number. Right. Explain why this is a composite number. Method of doing, there will be a common factor in these two terms. Why two terms? Plus or minus sign separate terms. Can you see a plus sign in between? Okay, the part before plus sign is the first term. The part after plus sign is the second term. So how many terms are here? 2 terms are there. Okay, multiplication together is considered as a term. So 7 into 11 into 13 is the first term. Then 13 is the second term. So there is a common factor in these two terms. What is the common factor in these two? 13 is the common factor. So we start like this. 7 into 11 into 13 plus 13. We will take out the common factor. What is the common factor, children? 13 is the common factor. Okay, that is a method of starting this type of question. And then when you take out 13 from the first term, understood how do you separate the terms? Plus sign separate the terms. Okay, 13 when you remove, we divide by 13. That is the meaning. So then what will remain here in the first term? 7 into 11. In the first term, there is 7 into 11 plus. In the second term, what will remain? 1 will remain because division is a process. Taking out common factor means what happens there? 13 by 13, right? What is 13 by 13? It is 1. Is it clear? So second term will become 1. So no doubt, please note down that in the reference space. In the second term, this is happened. 13 is taking out means 13 by 13, it is 1. Now we will simplify this. 13 into, now 7 into 11. What is 7 into 11? 77 plus 1. That is 13 into 78. Okay, which means 13 into, now 78 we can factorize. 78 is divisible by 2. And what do you get? 39, right? 3 2s are 6, then 9 2s are 18, right? Then again 39 is divisible by 3. So how much we get? 13. So then 13, 1. That means we got 13 into 2 into 3 into 13. Or it is 2 into 3 into 13 square, right? Which means it is expressed as a product of prime factors. By fundamental theorem of arithmetic, we studied every composite number can be expressed as a product of prime factors. Is it clear? Or it has more than 2 factors, or it is expressed, which is expressed as a product of prime factors. We studied every composite number. So this is what type of number? It is a composite number. So we write this is 2 into 3 into the 3 into 13 square. So since okay, so then we'll write it is expressed as a product of what type of factors? That is, it is expressed as the product of prime factors, as the product of prime factors. Therefore, by fundamental theorem of arithmetic, therefore by fundamental theorem of arithmetic, this number 7 into 11 into 13 plus 13 is what type of number? Is a composite number. Is a composite number. 7 into 11 into 13 plus 13 is a composite number. Yes, please write this one. So this is the method of doing this type of question. We have to take out the common factor and then we will simplify it and get the answer. Okay, got the idea? One more question is there of the same type. One more question of the same type. This all you have to write and practice. Okay, after going through, you have the last year's notebook is there with you. In that one, lot of pages will be there. So you have to use that page. Okay, for what? For doing the rough practice. Okay, the practice mathematics you have to write and practice. Okay, in between I will ask your parents whether you are practicing at home. Okay, you have to show this one to your parents in between. Yes, I am practicing by writing. Okay, then when I ask them, they will convey that message to me twice. Now practicing or like before. Okay, like this, they will convey the message. Okay, so you have to do like that. Okay, sincerely, everyone should do. It is not for a showing off, instead for your okay betterment. You have to practice. Now the next is explain why. Please write. So explain why. Explain why 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is a composite number. Please write. Explain why 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is a composite number. Yes. Here, how many terms are here in this one? Yes. So what common factor we take? 5 will be the common factor. Yes. Please try to do the same way. I will give you 1 minute or 2 minutes to try this one. Everybody, please try this by taking the common factor outside. Done. Finish. Abhirami, got it. So what is the last step? You got 5 into 1009. Can we factorize again? Plus 1. Because we have taken out 15, 5, right? Second term is plus 1. Is it? Plus 5 by 5 plus 1. So 1009 you got. 5 into 1009, all of you got? Yes, those who have doubt, please listen. You have taken out 5. When you take out 5, it is 7 into 6 into 4 into 3 into 2 into 1 plus, what is the second term? 5 by 5, that is 1. Sharon understood that. Plus is a sign. Mistake should not happen. Write and practice, okay? That like this mistakes happen, you specifically note down and at home practice again, okay? So it is plus. 1, you understood how 1? Ira, 5 by 5, right? 5 by 5 is 1. So we get 7 into, 5 into, then what is this? 1008, then plus 1. Steve, did you get? Write these steps. Then I will continue. Write this one. Is it clear that common factor 5 is taken outside? You have to spend more time, okay, for practicing, because fundamental some problem is there. So you have to rectify that by practicing. Okay, I can rectify, but you should spend time, okay? then plus 1, because 5 by 5 is coming. Tosh got these steps? Okay, so we get 5 into 1009. 1009, my question was at this point. Okay, 1009 can be factorized again. Last question, I got 78, then I factorized. Okay, why can't we factorize this again? This is a prime number. 1009 is a prime number. 5 is a, so, but it is expressed as a product of prime factors, right? At least 2 prime factors if it is there. So it will be what type of number? It is a composite number. So then we'll write the same conclusion. So how will you write the conclusion? It is expressed as a product of prime factors. Clear? 1009 is a prime number. Because we should express it as the product of prime factors. That is our fundamental theorem of arithmetic. Every composite number, continue, can be prime numbers. We should get prime numbers at the end. Understood? School, you will get the mark, but board exam teachers are very strict. They will specifically check. School, you will get, I am sure, because the same teacher is correct. Board exam, is it the same teacher correcting? No, we should write the perfect answer. Okay, that word also how to mention which one. By fundamental theorem of arithmetic only it is expressed. Okay, especially the paper which is getting more than 95% and all. They will check again this type of minute things. Okay. So you are aiming for that, right? The perfect mark, yes. So, right, okay, practice like that. School, it is fine, no problem. Okay, you will get the full mark. So we get 5 into 1009. Then how will you write this one? It is expressed as the, product of prime factors. Therefore, by fundamental theorem of arithmetic, what do you write? 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 1 is, what type of number is a composite number? Because that is our fundamental theorem of arithmetic statement. Every composite number can be expressed as a product of prime factors. Yes, at the end we express it as a product of prime factors. All are convinced with this one, last step, right? Yes. So that is the reason what we write this as a composite number. Is it clear? Yes. So this type of questions also comes in the examination for 2 markers. These are 2 markers question. Okay. She said today in the class test, she got a class test today. Classes started in some classes. Okay. So she got this question. So this type of question comes in the examination. Okay. For 2 markers. Next, word problems are also there in this part. That means the practical application questions applying this concept in a real life situation. That type of questions are also there in this part. Okay, so write that type of a question, word problem. There is a circular path. Right, there is a circular path around a sports field. There is a circular path around a sports field. Full stop. Sonia takes 18 minutes, 18 minutes to drive one round of the field. One round of the field, while Ravi takes 12 minutes for the same. 12 minutes for the same. While Ravi takes 12 minutes for the same. Suppose they both start at the same point. Suppose they both start at the same point. Suppose they both start at the same point and at the same time. And at the same time, and go in the same direction. Go in the same direction. Full stop. After how many minutes? After how many minutes will they meet again at the starting point? Will they meet again at the starting point? Will they meet again at the starting point? So please read this question. You have seen stadiums for a sports field, right? In sports field, there will be middle, there will be like a football court and all will be there. Okay, the grass field will be there. Around that, the circular path will be there. Okay, normally elliptical or circular, normally it will be. So here it is given circular path. Okay, so there is a circular path around a sports field, a circular path around a sports field. Then, so two persons, Sonia and who is the other person? Ravi. Sonia and Ravi. Sonia and Ravi both start at the same time, right? At the same point. Both of them, they start at the same point. Okay. Then Sonia takes 18 minutes to drive one round of the field. Sonia, she takes 18 minutes. Sonia takes 18 minutes to drive one round of the field. 18 minutes she takes. Okay, to drive one round of the field. So this time taken is 18 minutes, 18 minutes. While Ravi takes how much minute? 12 minutes. Ravi takes 12 minutes. So Ravi starts like this and goes like this and he takes 12 minutes. Okay, Ravi takes 12 minutes. Sonia takes 18 minutes to drive one round. Ravi is faster. He takes 12 minutes. Okay, then suppose they both start at the same point. That same point is a common point. Common point means we have two options, highest common factor or lowest common multiple, and we'll find out which one it is. because of the same point. From the same point, we can get the idea that there is a common point, right? The word common is hidden in that part. Common, okay? Then, and at the same time, okay, the same time is also for common, and go in the same direction. After how many minutes will they meet again at the starting point? Starting point means the same point, right? Where they start. Okay. That means first they started here, right? After how many minutes? So they are moving like this. And who is faster? Ravi is faster. Okay, maybe Ravi may takes more rounds. Okay, that doesn't matter. But they will meet in between. But we have to find out their first meet at the starting point, right? First meet at the starting point. Are you getting? First meet at the starting point means it is least common multiple, because first meet at the starting point. First meet at the starting point. Okay. First meet at the starting point. Are you getting that idea from that words? Their first meet at the starting point means we find out the lowest or least common multiple. What is that? Least common multiple. So we are supposed to find LCM of 18 and 12 for this question. Is it clear? So this way, we have to identify the question for LCM or HCF. These are case study or application questions may be asked this time. Okay. So are you getting clear idea? Any doubt? Okay. So please note down this using pencil in the question itself, because later when you study, you have to get the idea from where we get that common, that point. Okay. Then from this part, will they meet again at the starting point? Means their first to meet at the starting point means it is the least, right? First to meet at the starting point means it is least. Using pencil, you can note down that one in the question itself. Yes, those who attend online, did you understand the idea why this is a LCM? So then we write required time is equal to LCM of 18, 12. Required time is equal to, or time taken is equal to LCM of 18, 12. Yes. Now we factorize 18, factorize 12, and the same method of prime factorization, you will find the LCM. Can you try doing that one? Yes, please factorize 18. Then you will factorize 12 to find the LCM. Those who finished, you can send the answer on the chat box. Attendance in between. Aaron again absent. Then Abhirami is present. Akshita, Alicia, Angelina, Ira, Benita, Chris Isha Thomas, Halima, Joanne, John Biju, sorry, Josh Biju, and then Chris, Raveliga, Rafika, Raswana, Sarah, Sarah, Sharon, Steve, then Sharon. Okay, this number 5652411 whose number? Is it Ira? No, Ira already added, right? Okay. Okay, okay. 5652411, right? Okay, you joined through the link, right? Okay, okay. So your full name? Akshita, okay. And Akshita is in senior, right? Okay. So children, you got the answer. 18, how do you factorize 18? 2 into 3 square. Then 12, how do you factorize? 2 square into 3, yes. Now the LCM is 2 square into 3 square. 2 square is 4. 4 into 9, answer is, and what will be the unit? Minutes. Therefore, the time taken after 36 minutes, they will meet again at the starting point. Like this, we can write the conclusion, okay? Therefore, after 36 minutes, they will meet again at the starting point. They will meet again at the starting point. Okay, so this is the completion of this question. So all of you can study and please set a timetable at home. As I told you, have a timetable, proper discipline timetable in school. The same way, you also have to make a timetable at home and go with that plan, okay? Right from the beginning. And then you can easily study the daily things on the same day itself, okay? Those who have the basic problems, please spend more time and If there is any basic problem, please don't hesitate to ask me. You have to ask and clear your